Okay, here we want to look at something called finding the area of a region between two curves. Now, usually when we find the area of a region, we have squares, okay? That would be the length times the width. Also, we may have rectangles. That again is the length times the width, okay? Sometimes we have perfect circles. The area would be pi r squared. And then in addition, sometimes we have just hypothetically right triangles. So we know the area here would be 1/2 the base times the height. But we don't live in a perfect world, so sometimes we have to find the area of imperfect objects. So here we want to look at the area between curves, between lines. We have y equals x squared plus 2, y is equal to x is equal to 0, and x equal to 2. So the first thing we want to do, I'm just going to draw sketch y equals x squared plus 2. That's parabola shifted up 2 units. I'm going to try to draw that as perfectly as I can. Okay, now we have y is equal to x. Now, if we know y equals to x, we know that's a straight line going directly through the origin. Okay, so now we want to graph x is equal to 0. Okay, and we also want to graph x is equal to 2. All right, so now the thing we have to look at here, we have to find that region. So what we're trying to do is we're trying to find this region that's trapped between these curves. And that's what finding the area beneath the curve is all about. All right, in a nutshell, you can see that's not a perfect figure. That's not a perfect triangle. That's not a perfect square or anything, but we can still find the region right here. So that's what it's all about. Okay, so now how do we go about finding this region? We want to, excuse me, we want to subtract the top curve minus the bottom curve, as we can see right here. I'm gonna put the spotlight. Top curve minus the bottom curve, and our boundaries from A to B. So in this point, let's set it up. Okay, in this point, it'll go from what, 0 to 2. That's already given to us. Let me get my size right. So that will go from 0 to 2. Now, what will we write? Our top curve. As a matter of fact, I'm gonna draw it out here. Yeah, that's going to be x squared plus 2 minus x. Now, if you can see that, that's what the top curve minus the bottom curve. That's what we're looking to do. We're not straying away from the formula, we're staying with it. Now, one thing we have to remember, anytime we deal with a polynomial, we want to go in descending order. All right, so we have x squared minus x plus 2. Okay, let's raise that to the second power. Only thing we did right here, we got it in the descending form. And now what we want to do, we want to find the antiderivative. Now, believe it or not, even though this is calculus, this is the only step of calculus that you'll actually need. Everything else is really a high-level algebra problem. That's x cubed over 3 minus x squared over 2. And I'm going to come back and put everything in there. And that's plus 2x. That's x cubed over 3 minus x squared over 2 plus 2x. That's our antiderivative. That's really the only thing that we've learned in calculus 1 that we've brought forward to do this. Everything else that we do is pretty much algebra. Okay, it's just putting everything all together. Now we remember, once we set up the indefinite integral, first thing we have to do is come in and plug the 2 in, minus 0. Now, in this case, one thing we know, 0 times everything is 0. So let's go back right here. So we have 2 cubed over 3 that's 2 cubed over 3 minus 2 squared over 2 plus 2 times 2. Let's put everything back in. And now you can really start seeing this problem unfolding. Now, I want to note this, and we won't do this every single time. The second part is 0, so we're not even gonna do this part. Okay, the second part is gonna automatically put 0. I'm just gonna put a huge 0 over here. All right. In other problems, of course, using the fundamental theorem of calculus, yes, we would go over there. So now, 2 cubed, that's going to be what? 8/3. Now, 2 squared minus 2, that's 4 over 2. That's 2 cubed minus 2 plus 4. 2 squared over 2, that's plus 2 plus 4, which gives us 8/3 plus 2. And you can rewind this and kind of simplify it and find out what we need to find out here. 8/3 plus 2, when we get that common denominator. You know what? I'm just going to show it anyway. Let's move this. Moving all of that out of the way. Yeah, 8/3 plus 2, that's going to be 8/3 plus 6/3. I want to slow it down. Remember, we have to get the common denominator. That's the other aspect of algebra that goes into it. Yeah, that gives us 14/3. So that's pretty much how we find the area of the region between curves. All right, we can graph it, we can shade that region. Like we said, it's an imperfect region. It's not a perfect square, triangle, or circle where we already have a preset formula. All right, and this is how we do it.